yesterday we left off with the question, why are some stars brighter than others? We are going to do an experiment today which will demonstrate this. In this experiment, we will demonstrate the two different things which cause stars to have different brightnesses. On the first page, you have two different boxes to fill in. The first box tells you to write down what supplies we are going to need for the experiment. For your experiment, you are going to need 2 flashlights. The other thing you are going to need for our experiment, a lamp. 2 flashlights, 1 lamp. So my question for you, what things do you think are going to affect the brightness of the lamps or of the stars? Zach?
If they're closer together, it will make it brighter.
So distance. So if it says, what steps would you like to take? How might we check to see if distance affects brightness? What?
You put one there, you turn it on, and then you put one there.
Okay, so we're going to put the 2 flashlights at different distances. So write that. The first thing we're going to do is put the 2 flashlights at different distances. What else do you think can affect the brightness of a star?
How close they are to us.
Okay, so that we're just going to count that in the distance. But yeah, how close it is to us. What do you think?
How big they are.
Size.
Yeah.
So the other thing we're going to check, first off, was distance by putting the 2 flashlights at different distances. Step 2, use 2 different size lights to see if it affects the brightness. So that's where this and this come into play. So we're going to check distance. We're going to see if distance affects brightness. And then we'll see if size affects brightness. Our first experiment is going to be to put the 2 flashlights at different lengths. Will you hold that for me? Will you hold that for me?
Josh,
What the heck are you drawing?
stars.
It's dark.
You're right. You're drawing stars.
A moon.
No, I'm just drawing a dot.
That's not a big dot.
To the left, I drew a green dot. To the right, I drew a blue dot. Lily, turn the flashlight on and point it at the green dot. Okay, go ahead and turn it off.
Are we playing FNAF 4?
No.
Macy,
FNAF.
okay, turn it off.
Shadow.
One more time. Lily, turn it on. Turn it off. Macy, now, both of you, point them. Both of these are pointing at the exact same whiteboard. The green dot is being pointed at by Lily. The blue dot is being pointed at by Macy. The 2 flashlights are the exact same flashlights. The whiteboard is the exact same whiteboard. All I changed was the color of the marker.
Who's doing the puppets?
But is
No one's doing it.
the light the exact same light?
No.
No. What is different about them? Raise hands. Say Tucker.
Macy's further away and Lily's closer.
What difference does that make? For Lily to be closer and Macy to be further away. Anna Lily?
Lily's is brighter than Macy's because she's further away and she's closer up.
So what you're telling me is
The light
if a light is closer to you. Oh, there's something in the way of that. My bad.
It's so bright. It's so bright.
Move up. It's so bright.
I can see it. You can really.
Which one's brighter, Zach?
Ah!
Which one's brighter?
I would say that one.
Which one's brighter, Archer? If the light is closer to you, it is brighter. On the right page, in that first box, it says, what did you do? We moved a flashlight closer. In the right box, it asks for observations. So write down what you noticed. The closer flashlight was brighter.
Definitely brighter.
Now we are going to do the second of our experiments. We are going to test the brightness based on the size. Ray, remind us, point at one of the dots. Smaller light, pointed at a dot. Bigger light.
I can barely even see my light.
Okay, let's remind you. Show us, Ray. There's the smaller light.
It's a big light. Hey, Mr. Pratt. Mr. Pratt.
So,
Why do we always have this as a line?
point it up there. I said point it up there. No, I said point it up there. Oh wait, he is. And I can barely see it. Why is it that I can barely see his flashlight?
They're technically both the same sizes. I mean, brightness. But the lamp's bigger, so it takes up more room with light. So they're technically the same size, but that one's brighter just because it has more room.
So you're telling me, because you're on the right track, you're just a little bit, if I put these the exact same distance away from that wall,
I can see it. I can see it.
Uh,
I can barely see it.
so
there.
what is happening here, Harper?
So it's like the big light, the little ones feel shiny, I guess. But the big one's just like bigger, so it takes over more.
So if I wiggle it around, you can see that light's making it up there.
Yeah, but that one has more power.
But why does this one have more power?
Because it's bigger.
Because it's bigger. In the second boxes on that right side of the page, what did we do? We used two different size lights. And then write down your observation. Write down what you saw. So we've conducted two experiments here. Number one, we used the same size lights and put them at different distances. We learned from that a light that was further away is going to appear dimmer. The light that is closer will appear brighter. And then in the second experiment, so in that box there, we used two different size lights. And our observation with that was the bigger light is brighter. What?
Is it a small star, but it's just closer to Earth?
We'll actually talk about that tomorrow. We're going to get into the actual size and scale tomorrow. So on the bottom half of this page, I'm going to change the directions from what they have there. I want you, in a sentence or two, you can easily do it in one, to write me a summary of what we learned today and how that relates to stars. So we're going to translate it from light, light's like this, and we're going to translate that into stars. So stars that are closer appear brighter. Stars that are bigger appear brighter.